Well, good evening, everybody. My name is Bert Dicht. I am the Managing Director of Membership for the National Space Society. And on behalf of my colleague, Larry Ahern, Vice President of Chapters, I'd like to welcome you to our Space Forum this evening, the Launch Director's Perspective. So thank you for joining us tonight. So what I'd like to do is I typically go through our agenda. So we're going to do some virtual etiquette. We'll have some quick announcements that I've shared the last time as well. What's coming up with Space Forums, and then we'll get right into our program for tonight. And I know you're looking forward to it. So as always with our virtual etiquette, feel free to submit a question using the Q&A function. That works best because it's easy for us to pick the questions out and then ask our speaker. So I encourage you to do that, but also feel free to use the chat function. I only ask that everyone be respectful of the speaker and our audience because everyone can see those. But we welcome all the great comments that we typically get. So thank you in advance for paying attention to that. As always, too, if you are enjoying the programming like this, these space forums and town halls, I do encourage you to donate to support NSS. We are, of course, a not-for-profit, volunteer-based organization, and your donations really help us advance our mission to create a spacefaring civilization. We got a number of donations last week, so I wanted to thank those people if they're on again tonight, and thank you in advance for making any donations. And I will be putting the link into the chat as we move through the evening as well. Finally, complete the post-town. Oh, it should say Space Forum survey. So complete the Space Forum survey at the end. It only takes a few minutes to do it. It will go right into it once the session ends. It's anonymous, and the feedback always helps us in planning these events, and we really do appreciate your comments as well. One big reminder, it's actually now 2 weeks until the ISDC. Sorry about that. I didn't update that slide, but it's 2 weeks from today it starts. This is the 42nd Annual International Space Development Conference in Los Angeles. It's a great event. We have an amazing lineup of speakers and presenters. Our theme is No Limits. Great sessions, everything from space solar power to Mars to many roads to space. We're doing some real fun things at the conference. And my next slide, I showed a different group of speakers last week and just wanted you to get an idea of some of the great speakers we have. Again, you probably all know Robert Zubrin, president, of the Mars Society and of Pioneer Astronautics. A lot of great individuals. This, again, just a handful of the individuals that are going to be there. And also mention that William Shatner is going to be there on the Friday evening to accept a big award from the NSS. So that should be a lot of fun. So hopefully you can make it. There's still plenty of time to register and get out there to Los Angeles. So I definitely encourage you to do that. One other thing I did want to mention that I don't have in my slide deck, but I mentioned it last week, we are working again on the tour of the Kennedy Space Center. We did that back in January. It was really great. We've got a lot of great feedback. We're going to be doing this again on the 19th to the 22nd of September. So we'll be sharing a lot more information as we move forward, but I will put a link into the chat. So you can go to the site and just take a quick look. And if you want to, put your name on an email list so we can get you information. But if you remember, you're going to be hearing about it, and I'll be sharing a lot more about this during future town halls. So hopefully we'll be able to see you here on the Space Coast in September. Upcoming Space Forums. We don't have anything scheduled for June. I've got 2 dates lined up right now, working on a couple of different speakers, and also trying to line up July as well. So look for the announcements coming right after the ISDC, and that way you'll be up to date. So there won't be any more until after the ISDC. So June 16th. So probably early in June, we'll be sending out the announcement for the first Space Forum. So hopefully we'll see you then, but we always appreciate your participation. So now it's my pleasure to introduce our program for the evening, and I know you're really going to enjoy it. And it's the Launch Director's Perspective with Bob Sieck. Bob is a graduate of the University of Virginia with a degree in electrical engineering. He went into the Air Force after graduating and rose to the rank of a first lieutenant. Was actually a meteorologist in the Air Force, so maybe he'll be sharing a little bit more about that when he gives his remarks. But after leaving the Air Force, he came to the Space Coast, went to work for NASA in 1964, and has an almost 40-year career at NASA. Of course, he worked on Gemini, he worked on Apollo, and became a launch director on the Space Shuttle program, and was responsible for more than 50 launches. So we're hearing more about that now. As he's retired from NASA, he's staying very involved with issues involved in spaceflight, working with the NASA Advisory Council and the SpaceX Safety Panel. He's also involved with Habitat for Humanity, at the Astronauts Memorial Foundation, the National Space Club, the Astronaut Scholarship Foundation, the NASA Alumni League, and the American Space Museum. So he keeps pretty busy. So we're really excited to have him here today. And what I want to do now is stop sharing so that I can introduce Bob. And Bob, it is all yours.
Okay, and yeah, well, thanks, Bert, and good evening, everyone out there. So what I'm going to do is go back in time and walk through the various programs and my participation in them, and how that led up to me being launch director for Shuttle, which is a job I never sought, by the way, but was privileged to have, and actually privileged to be part of the great adventure, I call it, of putting people and payloads into space. So we'll start out. Why don't you put the first chart up there, Bert? That's the historical one that's got all of the slides on it.
I will do that.
And I'll go from there. So Bert mentioned the Air Force. I did not. I was not a participant in the Mercury program because I was training and operating as a meteorologist for the Air Force at various places around the country, and ultimately ended up in activating missile silos out around Tucson, Arizona, where the weather forecasting was really easy, but the any event that occurred in that silo with that rocket and all of those propellants and ugly warhead on top could have been a major event if something happened. So the meteorologist's job was to say, well, okay, if you got to close these roads and evacuate these facilities, this is what the current meteorology is, and it'll tell you what to where you got to take action. I kind of felt for a while I was wasting my time as a meteorologist, but it turned out that once I got into the launch decision process, and weather became one of those few judgment factors that was kind of up to the launch director if the weather really is good enough. It came back to bear some good for me. So what I took away from my Air Force years was a sense of discipline, accountability, responsibility. And when I entered, I graduated when I was 21 years old, essentially young and clueless, got married, got commissioned, and back then, if you were an able-bodied young male and not in college, you were going to spend time in the military. So I figured the best way to handle that was be in the ROTC and be able to, in some respects, make my own wake, so to speak, with the decisions. So So I was enamored by the space program. I was in college when they launched Sputnik. First time I came down here, my parents had just moved to the beach area in the Atlantic, and I was able to. Back then, you could drive on the beach, and I remember driving up there on spring break one time, looking up at the Cape, and the lights were on one of these rockets they were trying to launch. And I said, you know, if I ever graduate, I ought to come down here and live and get a job doing that. That would be a lot of fun. And since the Air Force was in charge of everything at that time at the Cape, NASA was still not a player yet, although they were getting ready to build the Kennedy Space Center. So I figured, well, I could do a career in the Air Force because my dad had been career military, and I could do it that way. So, but unfortunately, they didn't have any openings for me. I tried a few times while I was a meteorologist, so I took my discharge and hung the uniform up. But a takeaway from my years in the Air Force was I learned what responsibility and accountability is all about, and that came to play. I recall the colonel that was my boss telling me, he said, okay, it's your job's important, Lieutenant, and so's your authority. Because when you sign this flight clearance for this pilot to go to that destination, there's two signatures on it. One is from base ops, and it's the person that says there's air in the tires and there's gas in the tank, and your plane's ready to go. And the other is a weather officer that says, here's what the weather's going to be like en route. Your destination is forecast to be in spec, and here's an alternate over here if something goes wrong that is in spec. And you make sure you brief that pilot on that when you sign this, because when you sign it, that's your warranty that he is, most pilots were guys, he is go for his mission. And you can fully expect that someday, depending on how long you're a meteorologist, you're going to be standing in front of an investigation board with your right arm raised, testifying that that's exactly what you told that pilot before he took off. So that stuck with me. When I joined NASA in 64, I was assigned the responsibility of biomedical instrumentation for the astronauts, beginning with the first Gemini flight. Really neat job. I was a member of a team with the flight surgeons. There's one assigned to each astronaut, and the technicians that handled the suits and the medical instrumentation system, which was a crude set of sensors and signal conditioners that went inside the suit and a cable that connected to the spacecraft. The engineer's job was to make sure that the signal got into the spacecraft telemetry system, was digitized, all analog data then, and then sent to the blockhouse and mission control, which was also at the Cape at that time, and then go, transferred from digital to analog, so the readouts, so the flight surgeons could see the electrocardiogram, respiration rate and depth, the phonocardiogram, what the doc listens to with a stethoscope, and blood pressure. And we also flew a lot of medical experiments. So if you want, Bert, you can show the photos. Let's see, that would be numbers 2 in the second, third chart. Yeah. So there's a Gemini blockhouse. If you look closely, you'll see there's no digital data there. It's all meters and recorders and paperwork. The guys to my right and left are the flight surgeons, and that console is directly in front of the test conductors, and the guys in the background are other spacecraft people, contractor, and NASA. I'm appropriately attired in my uniform of the day for young engineers: white shirt, short sleeves, narrow black string tie, and a pocket protector that's got enough writing instruments to last me for a year probably. Next chart. And yeah, that one. The reason I've got that one here is that was Gemini 6, one of the launch attempts. The launch attempt where the engine shut down just before liftoff. And it shows that, in some respects, the tension that we, myself, and the two flight surgeons are listening to the chatter on the net with all of the safing going on and watching the heart rates, and and you can tell we're pretty much focused there. A and interestingly, the sometimes the astronauts, in this case Gemini 6, so that was Shaw and Stafford, the astronauts' heart rate was pretty much steady around maybe up to 80, 90. I think one of them got it to 100, but nothing bad. And then a couple of minutes later, maybe 5, 10 minutes while the safing was going on, their heart rate started increasing. And I remember asking the flight surgeons, I said, "Well, they're not scared, are they? They're not acting like it." He said, "No, they're mad." He used a different word. He said, "But they just realized they're not going anywhere today, and no telling what the problem was with the engine before they go. And this is what your heart rate does when you get mad. So notice." But I'll finish the Gemini discussion by saying one of the things my boss told me when, and all of us new engineers when we came to work for the first time and we're getting our indoctrination. He said, "Okay," he said, "now most of you have spent time in the military," and we had because of the draft back then. He said, "So you know what discipline, accountability, and responsibility is. Well, that's," he said, "the way you got to look at your job now is you're still in a government agency, and so you got trained by the expense of the taxpayer, and that makes you a national asset. And we're going to the moon. That's a government mission. So you can need to act the same as if you're in the military, just not wearing a uniform." And for me, I said, "Okay, this is serious business. I get it. Silent salute to the boss, and we'll proceed." I learned quickly about the discipline thing. It wasn't too much later when I walked into the blockhouse, and it was the first time actually. And I had my procedure and my brown bag with my lunch and my headset, and I just stopped right in front of the test conductor's console. First of all, because I had to find my console, but I was just in awe of the hum in there, all the lights and whatever. And this very gruff voice from behind the console next to me said, "Son, sit down, put your headset on. This is serious business." And okay, I did that. That guy was, I would meet him a lot during my succeeding years as a spacecraft engineer. Anyway, um, the so Gemini led to at the end of the program, we were phasing down, but Apollo was building up. So now we became employees of the Kennedy Space Center. We were still launching from the Cape, but they were building Complex 39, and we had Saturn I launches from the Cape. Apollo 1 was, I was not assigned to that. I was working the first unmanned spacecraft that would go on top of a Saturn V. And my new boss, since I was now a test team project engineer, and what does that mean? Said, "Well, you're responsible for if the test procedure doesn't work, and it's an integrated spacecraft test with a lot of systems powered up in the spacecraft. In my case, it was the command and service module, not the lunar module. The If the procedure didn't work, then the test conductor of the test handed the responsibility of sorting out the problem to the project engineer. And the project engineer's job was to get the engineers who had been affected by this together on the comm system. and sort out whether the problem was the hardware, the requirements. A lot of times the design center people didn't realize how their hardware works when it's in a spacecraft with other systems on the ground with the limited test equipment available. Sometimes it's a procedural error, very seldom a software error because we didn't have much in the way of computers back then. And so that was the project engineer's responsibility. And as a result, we were busy round the clock, 7 days a week. Um, it was like a 6-year marathon for most of us. One of you had asked about, wasn't that tough on the family? The short answer is yes. Only the strong survives. Thankfully, my wife took it to task to make sure that my kids grew up in spite of the fact that dad was, even when he was home, was focused right here on what was going on at the Cape, where I spent easily 60 hours a week for weeks on an end. But we enjoyed what we were doing. We were anxious to get it done, and the um, the bosses made it known to us that their priority was to make sure that as their employees, we succeeded. If they told us, you don't worry about what it costs, if you need something, you just ask for it. The refreshing part of the environment was not only the challenge of the work, because engineers like problems, right? I mean, that's what we enjoy doing, solving a problem, getting on with it. But the boss's attitude to us was, if you made mistakes or things went wrong, and there was plenty of that, as long as you didn't do something irresponsible, they would get with you, and sometimes it was in groups. And he'd say, "Okay, Bob, now it appears you screwed up here. At least that's the way it looks. Let's understand the root cause of the problem, because we, management, my boss said, we got to fix it. And is it the environment you're working in? Is it the tools we gave you? Is it the procedures that we gave you? And let's sort out the root cause of the problem, get on with it, because Bob will never make the mistake again. But Luke, when he's doing a similar task, and we were all guys back then, we didn't get our first female engineer until a couple of years later. When one of your teammates, your colleagues, does a similar task, we don't want it to happen again. So tell us, management, what we need to do to set you up to succeed. Great environment to work in. It's one of the reasons we made it to the moon. And the other was, of course, we're a competitive nation, right? And the Russians are trying to get there before we are. And you know how competitive events are. Nobody wants to be in second place. But the management approach was very refreshing. The bosses would spend a lot of time on the floor with the hands-on people, the engineers, and my boss's boss often would come by, call in the middle of the night or come by and just ask how how we felt about this spacecraft and the next mission. And I remember one time telling him, "Well, I'll be honest with you. We've been troubleshooting this short circuit, electrical short circuit in this computer system for weeks now, and it doesn't look like we're going to find the root cause. And it's probably not a good thing to go fly with, because since we didn't fix anything, we changed some hardware by just shotgunning it type thing, but had no idea whether we fixed anything. So I feel a lot better if we sorted out the problem." Well, it turns out they did. It turned out to be a crushed cable clamp against a wire. And and after that, the boss came back and asked me, "So, are you feeling better now about this?" I said, "Yeah, boss, I'm go for now." And but that was refreshing. They honestly cared about how we were doing and where we stood on what I'll call the pulse of the work. It's and was a refreshing approach to things. At the end of the program, they cut it off early, if you recall history, and Bert, if you would, you can show the chart. I think it's chart 4, where I'm sitting in the what I call the glass cage. There we go. Yeah, yeah, I'm the guy there. I'm a senior engineer now, so I now can wear a long sleeve white shirt with a narrow tie and a pocket protector full of useless writing instruments. And the other people back there with me are the equivalents from the contractors. The people in front of that are the test conductors, and the guy on the far right is the same one that confronted me when I walked in the Gemini blockhouse the first time, George Page, who would eventually end up being the first launch director for the space shuttle program. Okay, so moving on, so the program ends, and we use up the hardware that was made for the last 3 Apollo missions on Skylab. And Bert, if you want to show the Skylab arrangement, that's obviously the Saturn V vehicle with the parasol, as it were, and the Apollo telescope mount. And that was a rough ride for the Saturn V in the lab because if you recall history, the original sun shield on it broke off, tagged one of those, snarled one of the actually snarled both of the panels, but one of them, when the first crew got up there, they were able to unhook one. But that was a great medical lab for continuing the effects of longer duration space on the body. And what I did then was I moved over to the shuttle program. Now, we didn't have any hardware yet. We were in the planning stage, and part of the planning stage was to use our knowledge from processing Gemini and Apollo vehicles and try to influence the design of the space shuttle, because it had this fabulous advertising brochure that we're going to fly each orbiter 100 times. We're going to fly 24 times a year. It's going to be maintained just like an airliner. And although we were skeptical, in the spirit of here's how we can, not why we can't, we took a lot of our ideas to the design center, Johnson in this case, and tried to influence the design for maintainability. And regrettably, all of our ideas were told, that's a good idea, KSC, but where we are in the program, regrettably, you're too late, because this would now be the equivalent of a modification. So it would either add weight, add more time to the production schedule, and cost more money. And we can't afford any of that. So you're going to have to do the best you can. And as a result, the space shuttle, particularly the orbiter, was a magnificent flying machine, but it was a nightmare to maintain on the ground. And because the design just didn't lend itself to quick turnaround like an airliner, and that came as no surprise to us and the smart people in the program, but others were constantly after us to do better, change our procedures down here, and operate it more efficiently. And that's part of the schedule pressure that actually was a factor in the Challenger tragedy. But I don't want to dwell on that. So I was assigned as when they started the approach and landing tests out in California. I missed the Apollo Soyuz mission because I was already getting bedded down, so to speak, in Palmdale, where they were building and checking out Enterprise before they sent it up to Edwards Air Force Base to be processed for the approach and landing test. So when we convinced management that it would be a good idea to send a NASA component of the team that would be the core of the shuttle processing team, once we started getting the space rated hardware down here, and learn what that orbiter was and provide the government role in the oversight of the processing. So I became the boss, as it were, for the engineering component of approximately 100 NASA employees that were sent out there: engineers, operations people, inspectors, um, some safety folks, scheduling people, and some facility and ground support equipment folks. So I was a mother hen. My first job as a manager, as it were, for the roughly 2 dozen engineers that we sent out there. And in the meantime, since most of us got our degrees back in the 50s, where I was telling Bert earlier that the only thing I really learned in electrical engineering when I was in college was what a transistor was. And that's because I took the time to find out on my own course, because the textbooks when I graduated hadn't even caught up with that technology yet. So we had to go learn computers. And because the space shuttle was obviously a fly-by-wire system with real computers on board, and we had to develop a ground system that was compatible with that and have automated procedures and all the complexity that goes with that. And we had lost all that because we were too busy during the Apollo program. So we literally went back to school. NASA helped some with brown bag after work programs, but most of us had to take night courses and figure out what that was all about. So, so I spent 2 years out there. They had 5 free flights of the program, and it ended up being a success. We learned that the 100-ton glider called the Space Shuttle Orbiter could really be flown in the last 25,000 feet of the atmosphere, as long as it had enough energy at touchdown to still be maneuverable. So, so after the orbiter Columbia was sent, we started our campaign to the first shuttle launch, and at that time, I now became, instead of the engineering manager and the project engineer, similar job as the project engineer, but I was responsible for all of the integrated procedures between the orbiter and the tank and the boosters, and the launch commit criteria and all the requirements that went with that. And the other duty as assigned was also manage the ground launch sequencer program, which was the computer program that implemented the launch commit criteria requirements, and additionally is the main program that talked to the flight computers during launch count. So I learned all the ins and outs and the requirements associated with launching the orbiter and the rest of the shuttle stack in process. And so the workload prior to STS-1 was no different than what it had been in Apollo. When we finally got the orbiter under testing, we found that a lot of our procedures were inadequate. And I think I've told many people after the Columbia accident, said, well, the legacy of Columbia should be that it trained the shuttle processing team at KSC, both government and contractor. And it's if you want, Bert, you can show photos 7 and 8. The that's and in fact, yeah, that's what the control center looked like back then from the outside. From the inside, today, that's what the shuttle program, that's what the shuttle control room looked like at the end of the program. But if you go to the next chart or the next one, yeah, the next one after this, that's what the the control room looked like in early shuttle and on my shift. The when I first I had the job as the shuttle project engineer for the first 10 or 11 missions, and then the fella George Page, who was our chief test conductor in Gemini and in Apollo, he was the launch director, and he called me into the office one day after the first half dozen or so launches, and we had the chit chat type of discussion. And he said, "Well, Bob, your next assignment is you're going to be my replacement." And I was kind of taken back by that. I thought I was doing good, what I was doing. And he said, "Yeah, well, I'm going to have to leave. He's going to have to leave." He said, "You know where the slippery spots are in processing a vehicle and in launching a vehicle. You know the people, you know the requirements, you know the procedures. You're the best qualified to take the job." So uh, he said he's going to hand the launch director job over to his deputy for a few missions. I'm going to be the understudy for that, and then I'm going to take over as launch director. And so, okay, boss, uh, just like in the military, silent salute, and I'll get on with that. The If you notice in the control room, um, now we finally have computer keyboards, but there's no laptops like you saw in the lesson because they're not allowed yet because we don't. Well, first of all, there's no internet. There you can load your own programs onto them, but in '81 when we launched the first shuttle, there's no internet, so there's no reason to to clutter yourself with a lot of extraneous data. So we got small CRTs and little 8-inch black and white TV sets. Although up on the top row where the launch director console is, uh, just under the windows, there's some really neat 14-inch black and white TV sets, so you can see a better picture of the launch. Of course, we got a good view looking out the window, as you can see there. But one other thing that George Page, the first launch director, told me, he says, "Now remember, launch countdown starts whenever the vehicle comes back from a mission, because that's the beginning of a campaign. It's a number of tasks that all lead up to the last 3 to 4 days, where we take all the tasks, put them in one set of procedures, which is thousands of pages, and execute that. But your job really begins whenever the orbiter comes back from the mission and it gets integrated with the other elements that are coming from other places in the country." And as expected, the when we got ready for the first launch, we figured, well, I think we got a good feel for the hardware, but I'm not sure about the computers and the software. And sure enough, we got into the final count on the first launch attempt, and a computer glitch scrubbed the launch. Thankfully, it was on the flight side and not our ground stuff. Small comfort, but we launched the next day, and as you might expect, euphoria reigned in reigned in the control room. It's a great day. The Near the end of '84, I I was told to make sure I had a good replacement as launch director, because again, no choice. You're going to move up to management. You're going to you're going to be the boss, the line organization boss of the launch director, and you get to worry about running the 500 and some NASA personnel that are involved in shuttle processing, along with the budgets and the contracts and all of the work with Washington. And and to me, that was kind of a, well, okay, I'm still part of the team, but I really hated to leave the job that I never sought, but was very comfortable doing. And you'd ask, well, why were you comfortable? Wasn't there a lot of pressure? And well, yeah, there was always schedule pressure, but the launch team wouldn't let me do anything dumb. I had total confidence in if they thought something was going awry, that uh, they would tell me. The and you when you look at it, essentially, the launch director's job is to say no whenever you feel there's launch fever uh, that's reigning the decision process and leading the decision process. The the a launch director would never override a member of the launch team that's no go for whatever reason. And the launch team yeah, is everybody that's reporting on day of launch. It can be the range, it can be Houston, it can be one of the systems engineers in the control room, it can be security, it can be a support person or whatever. The if they're no, then the launch director's no go. The but there have been instances, I'll give an example or two, where everybody said, yeah, well, there go, or this will probably be okay. And that's what I call launch fever. And I said, no, we're going to give you more time to think about that or work on it and review the data when you're not as fatigued and pumped as you are now. So we're going to scrub for the day. Not an easy decision. And it's not about the money. Um, it's another fatigue cycle on on all the participants, and that's a factor. But it's also hazardous exposure. The space shuttle is by design. It creates a hazardous environment in the launch process. You fill the tank, and when it's filled, you got 500,000 gallons of liquid hydrogen and liquid oxygen in there. And you send a closeout crew, you minimize the number of folks. There's a handful, five, roughly five. You got to justify every one of those being there. They have to prepare the cabin and help with the crew ingress. There's an inspection team. Unfortunately, we don't have cameras that can see 360 degrees around every aspect of the shuttle uh, remotely. So they've got to go out there with their cameras and their sensors and look for ice, look for debris, or anything that we may be missing with the cameras that are remote from the control room. And in many cases, too many cases, some equipment will fail on the ground, either in the mobile launch platform, which is a terrible place to get in and out of in a launch environment. It's like the inside of a battleship, and you're flowing nitrogen through there into to the to the structure of the fuselage of the orbiter, and it's going in there. So you got to be constantly aware of nitrogen leaks and be aware of what's going on above you. Egress is not quick, and it's a bad environment. And but you send the judgment factor in sending out a red crew is, well, okay, here's a situation. There's a lot of equipment in there, and we've lost. Let's say we've lost the primary pump or electronics device or one of the pieces of the launch processing data stream. Say, okay, we've lost the primary, we switched the backup online, but if the backup fails, we're going to scrub the launch. Uh, and so what do, Mr. Launch Director? It's your call. This gets back to the responsibility thing. If you send them out there to repair it and you end up with one of those bad days, uh, and they're trapped in the mobile launch platform, well, guess who's going to be standing up in front of the investigation board saying, well, why don't you scrub the launch and do it in a safe environment? Yeah. Or even if the reverse happens, it's only one piece of equipment and uh, the guys say, well, we can go fix that. We have to go out there, maybe do this troubleshooting to verify it's that, and we'll take the spare parts we think we'll need, but we can get the launch back underway today. And if it's a long launch window, not a short launch window, we can maybe make it by the end of the window. So what do you do with that one, Mr. Launch Director? Not easy decisions, but somebody has to be responsible. And that's the essence of the launch director job. You eventually got to get to not saying, well, he said, she said, or we share this with ever. No, it's one person. If any of you were in the Navy, particularly back in the years, there's a saying from a Navy admiral who was famous for being he was the father of the nuclear submarines, and he ended up in Congress testifying when the first nuclear submarine incident occurred. And he said, I'm going, and he said something to the effect of, okay, I know what you all are looking for here. Who's to blame? He said, well, you're looking at him. I'm responsible for the safety and the design of that submarine. So you look no further if I'm responsible. And 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 there's a message in that. If you don't know who's responsible, then you really didn't have anyone responsible at all. That's but there's other decisions that, again, it gets back to the launch director. Some of the tougher ones are approaching tanking. That's about it for Shuttle. That's a 10-hour ordeal, and you have a meeting the 10 hours before tanking, and you look at the weather and everything that's going on and see if the open work, and you make a judgment decision whether the weather is good enough. That's where my meteorology training kicked in. And based on the forecast, and or this work can still be completed before you take the trouble and go through again the hazardous exposure of loading that tank up. It's the same thing with rolling out of the vehicle assembly building. Launch director responsibility. Assess the weather and the open work. And we usually did that at night because weather, particularly in the summer, weather's dynamic here. But we it's a it's the same process. You got to decide whether spend more time or the weather really isn't good enough. The and make the decision. There's and the other is team fatigue. It's I had to scrub at least a couple of launches. They said, well, we can try again tomorrow. If we meet this afternoon, look at this data and whatever. And I'd say, no, you guys that are going to have to review this, or you need to get some rest. So you get your rest. You use the rest of the day to assess the problem, and we'll meet again um, day after tomorrow and see where you got, and then we'll decide whether or not to go. And and I and I can say, and if my successors would say the same thing, we all had the same approach, and nobody ever said, well, you're not the right person for this job. Nobody that cared anyway. The other thing, and you need to be careful of that, because in some cases the team is, they want to go, and if you say, well, no, wait, I'm not, we're not going to do that. I think we're rushing to conclusion. It's kind of like pulling out the rug from under them. As the boss lost confidence in us, so the only way you abate that is to spend a lot of time communicating. That's part of the job. It's so I there's no a couple of things to mention. There's no magic button you push to launch. Actually, it's launched by a computer and a shuttle program. It's a woman, and it was a woman in the back of the control room that loads some numbers into the computer, and when the GMT clock reaches that point in time, it kicks off the computers, and there's no big red button. I think my most attention grabbing event was the first uh, launch abort we had on the shuttle. This was before Challenger, and I was launch director. This was after engine ignition and the engines shut down, and the crew's on board, and we have what's called a mode 1 egress, which is forget about collateral damage to anything getting out of the cabin. You just throw the hatch open, scramble out, run across the uh, the the swing arm up there, and you're 350 feet up, and jump into these slide wire baskets and cut them loose, and you take a slow ride down the egress slide, they call it, to a bunker that's at the edge of the pad about a quarter mile away. It's a tough call to make. Again, launch director decision, but also we had a chief test director by the name of Norm Carlson, a long time launch vehicle test conductor, veteran of the program, and he was trained to be the head of the Mode 1 egress team. And between the two of us, one of us had the responsibility to call it. So when this occurred, we kind of looked at one another. He's in the console right in front of me, and kind of shook our heads and no, let's see how it plays out. And so we turned the water on, the Firex water. There was a hydrogen fire there, but it was in the nozzle of the engine. But you could tell it was a fire because it was the cameras showed it was melting some of the tile, and also the sensors up on the further toward the orbiter cabin were showing a heat increase. So we turned the water on, which is not an easy decision, but because chances are it comes out of there with such force around the bottom, it'll damage the tile. And but at that point, you don't care. Um, anyway, upper management approach to that was afterwards. We went through all of our procedures, and we changed a few minor things, added more fire detector notifications to different consoles, and some of the protocols on the net while we're safing. And the administrator called everybody up to Washington after we had sorted out the root cause of the problem, which was the engines. And we each had to give a briefing. The engine people got most attention, the flight crew, and then at the end of it, it was the launch director's turn. So I went through about 15, 20 minutes of charts about all the stuff we looked at and whatever. And my final chart had two minor things on it. Was a fire detector, enunciate fire detector, and showing up at a couple more consoles, and a change in the comm protocol. And then the administrator had not been paying much attention to the briefings, and I got the impression he wasn't paying that much attention to mine. When I finished, he slammed his hand on the counter of the table that was around there, and stood up and said, "Son, you mean to tell me that's the only change you're going to make?" And I'm starting to, tremor a bit here. And I said, "Well, yes, sir." And he slammed his hand down again. And he said, "Well, good. I was afraid you were going to overreact and change a bunch of stuff you didn't need to change. Now, why don't you go fix your nits and go down there and get this thing in the air?" And I think I tried to drink all the beer on the NASA charter plane on the way back to the Cape after that one. The So let's see, Bert. To wrap it up, give you a chance to ask some questions. Um, go to
Oh,
the chart. Well, let's see the first chart again. Let's
for
go
sure.
back to
Okay.
the one that shows the history. And
Okay. Okay, there it is.
okay, so that's the that that pretty much that covered everything I wanted to. I want to just lightly tip on the. So I retired after the what we'll refer to as a John Glenn flight in late '90. I retired in '99, and immediately the administrator assigned me to the Aerospace Safety Advisory Panel. And and that kept me connected with the people in the business. I didn't want to do consulting work in my new career of retirement, but that was volunteer work. They pay you, government pays your expenses, but you're essentially a volunteer, and that's fine. Then Columbia happened, and they chartered a panel to headed up by astronauts Tom Stafford, rest in peace. We just recently lost him, and Dick Covey, um, to look at all of the changes NASA was making to implement the recommendations of the Columbia Accident and Investigation Board. And so that was another 2 years of work, as it were. And interestingly, our 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 panel's finding, which we gave to the administrator and Congress, was that, well, if the risk of debris hitting a vulnerable spot on the orbiter has been reduced, but it hasn't gone away. Um, So the plan to only go to space station and have repair technique and have another shuttle on semi standby um, is an approach to mitigate that risk, but there's still risk there. After that, I was on a panel set up by the space station to look at the safety aspects of the station and the continuation of shuttle. And the bottom line on that was the biggest issue associated with the station is on-orbit debris, which is going to get worse with time. And so you need to harden it the best you can. And for continuing to fly the space shuttle, it's once you finish the station, it's out, it's outlived its usefulness. There's no payloads coming down the pipe that require the services and the performance that it will give. And the hardware is getting old, and we're losing the original equipment manufacturers. So you can't find manufacturers to build a dozen of these valves or whatever, the tool up to do it, and pay the expense of certifying it. So retiring it is the right way to go, and put your emphasis on commercial crew, which in the meantime, yeah, you're dependent on the Soyuz, but at that time, thankfully, we had a good relationship with the Russians, at least. And I'll say this about the Russians: the people that I dealt with in the Mir missions, the engineers and whatever, were they were they were true believers in in the quality of the hardware and the safety of the crew, and extremely proud of their space program. And they were pleasant people to work with and talk to, and really dedicated. And it can rightfully be proud because, as you know, they were first in everything except conquering the manned exploration of the moon. And but they're rightfully proud of their program, and I think that's one of the things that keeps it going in spite of uh, today's issues. I will say one more thing, because if I don't, I'll forget it. The so I was asked more than once about, well, how big is the launch team, Bob? They're thinking of maybe 100 people in the primary control room and 100 people in the backup control room, and then you converge down to the final poll for launch. And well, and when a lot of people are listening and watching, I said, well, think of this. So here's a space shuttle example. There's 25,000 plus tile on there, and so here it is, the middle of the night. It's 3 months before launch, and the tile technicians are working on the vehicle because in the daytime, they require accesses. It's going to keep other people from doing, too many other people from doing their job. So they get relegated to second or third shift to do a lot of their work. And they've got this procedure here that talks about how you prepare the cavity and clean it and put the glue on the tile and pressure it for this long. And they're following this checklist. And as they go, they're either stamping it or initialing it. And when the job is complete and they've finished the pressure test and the pull test that say it's sticking, then they'll go to the final page and they'll sign it off and stamp it. They just gave a go for launch, just as important as the one the launch director does at T-minus minutes with the whole world listening and watching, just as important. And the important thing is those workers know that that work is important and therefore they're important. And that's what makes human space flight possible. It's all about the crew and their mission, and always should be. Okay. I saw some of the questions that you sent in. They're great questions. I could go through and answer every one, but that would preclude some of you to put up with this for the last hour to ask your questions. So back to you, Bert.
Thanks, Bob. That was great. A very interesting career, and I think you've settled a lot of questions about there's no button to push for launch. I think a lot of people ask that all the time. But let me get to one question that came in. It kind of combines it with some of the other questions. You know, last Monday, the Starliner launch was scrubbed because of a valve problem on the Centaur stage, and I saw Tori Bruno's press conference afterward, and we were just talking about the valve and the fact that had this been a satellite mission, it might have progressed differently. They might have been able to work it out and launch. But because there were humans involved, there was no, as they used the word, an abundance of caution, we're going to replace the valve. So I would just, could you comment a little bit on the difference between launching a payload that is just, a satellite versus payload that's carrying people?
Well, I think it's more like the decision to not change the valve and falls in that I call it in human spaceflight terms, that would be a finesse and a probably be okay and meet mission objectives. And for human spaceflight, that's just not good enough. There's a difference between accepting a risk and gambling. And when it comes to human spaceflight, that's gambling the safety of the crew on something that'll be probably all right. And that's not within the rules of human spaceflight. You can accept the risk of a of the valve malfunctioning again, and if it does, I don't know what the details are of this, but it could probably be, if it reseated and you got off the ground, once you start draining the tank, it wouldn't fail after that once it's stopped. But if the valve is doing something that's out of family and you don't know why it's doing it, then it's best to pull the valve out and see what's wrong with it. And seeing what's wrong with it is important before you replace it and just quickly go back out there again, because the substitute component may have the same inherent problem. Either it's debris or design margins or whatever. It could be anything, but you really need to know why that valve didn't act normally before you commit the crew to go fly again, or try again, better said. Yeah.
So
Yeah.
did,
And the rules are different. It's just, yeah,
right,
I recall Apollo 8. Apollo 8, we accepted a lot of risk by, we have one manned flight around Earth orbit, and now we're going to go to the moon on on top of a Saturn V, who the previous flight did not go too well with an unmanned spacecraft. If you recall your history, there was problems with the second stage. One of the engines didn't, they didn't receive, they didn't get the velocity they wanted, or whatever. So what the program did was said, okay, we're going to put the best hardware we got anywhere in the field out there ready to go. We're going to put it in this mission. So the engine in the service module, which is a huge engine, um, they, we had the performance data of all the test firings. Well, there was one test fired engine that had a higher ISP than the one that was in the service module. So we pulled that perfectly good engine out of the service module and put in one that had a higher ISP, just to give them a little bit more performance.
right.
And that's an example of what if you got a high risk mission, and any mission that involves a crew on it, then you give them the best.
Very good. You mentioned when you did your introduction that this was not a job you sought out. How has the position of launch director evolved? Because you rose up, you did certain things in your career, and someone said you'd be ideal to be a launch director. But are there now more specific training programs that lead to being a launch director, or is it still kind of like that?
I it's it well, the training with the team, if is it's pretty much a procedural um, process. And you get skilled, you get communicating with your control room team. It's it, in the execution of launch countdown. But I go back to, well, it's more than just the last 3 to 4 days of a campaign. It's the campaign from beginning and the end, and the campaign begins when you start receiving flight hardware, because all the bosses out there that line organization wise own either the government or the contract people. They're busy doing what I call boss stuff. Launch director has the flexibility, because he or she is not running a large organization. They got a small staff that supports them, and that's basically it. They are free to go out there, poke around, snoop, whatever, and talk to people and see what their issues are, or how the pulse is in during the whole process. And that makes you feel a lot more comfortable when you get into launch count, and you have to deal with the people that are higher up than you on the organization chart, as well as keep your mind and ears open to the people that are down lower on the organization chart, because they're all members of the team. It helps you a lot better to deal with it. And in a way it's fun. It's it's an enjoyable job. Um, it the desk jobs, the management jobs would put you here on the organization chart. Yeah, that's fine. You can feel real good about that, but I don't see the fun factor in it. No, no.
Right, right. There were a couple questions that were put in the Q&A and also in the questions that were submitted beforehand to kind of ask you about maybe your best and worst moments in the firing room, or is there the most memorable launch that you might have encountered? So I know you did more than 50.
Yeah.
Can you single them
Well,
out?
let's see. I'll go. Yeah, I'll go through these as your time permits. And so yeah, the best moment was, well, it's hard to say. It was either the first shuttle launch, because of the campaign it took to get there, or the first launch after Challenger return to flight, because it was tough to recover from that period, and it was a tough period. Uh, the layoffs that we had to incur, the the you know the sloop shouldered, I'll call it. That everybody had lost their confidence, and thankfully we had down here at the Kennedy Space Center. Anyway, we had a really fired up new launch director that helped rebuild the team, but we had definitely lost. Everybody had lost confidence in themselves, even though at KSC, there was small comfort that there was nothing we did that contributed to the root cause of the accident, but that's small comfort. We still, everybody felt bad. And of course, it didn't, we had to go through this process. It's unfortunate, but this is the way it works. Anytime there's a tragedy that has a technical basis to it, there's the shock and the grief of the loss, obviously. Then there's the emphasis on what went wrong, what caused it. Then, unfortunately, you get into the media gets into this who's to blame stuff, and that seems to dominate all of the airways out there, the newspapers back in the earlier days. And then while all this is going on, you're trying hard to get back to going again. So it's a tough period of time, and it isn't over with until you have another, in this business, safe and successful mission. It's yeah, that was probably that was my best, either one.
Right.
It's hard to say, because of the first launch, we said, are we ever going to get off the ground? It felt like that for a while. There's no buttons to ports, and there's no rituals amongst launch directors. I probably got a pair of socks or skivvies that launched more. I launched more successfully in than I scrubbed. Um, if Yeah, but no, the most memorable moment type thing. I had one other memorable moment, which I gotta mention, and this was after I'd finished my term as launch director, and I was given a tour to the family of one of the astronauts that had flown, and and near the end of the tour, his daughter came around, a very young girl, 9, 10 years old, and looked at me and said, "Thank you for keeping my daddy safe. Best reward I ever got
Wow,
in the
nice.
program." Yeah,
Yes.
powerful message right here. But that was uh, that was one of my better moments. Um, it, it's it, I always made it a point with the flight crews to talk to them before launch. We usually had a social out at the beach house, and with the families on launch day. The families would hang out in the launch director's office, which is above the control room, and I would usually go up there. In fact, made it a point to do it every time, to talk to the family, particularly if we were having issues. There was delays, and of course they're listening to the net, so they're hearing all this chatter, and they're not. And they've got astronaut support crews up there, but they like to hear from the launch director on what he or she is really thinks about the issues that they're listening to. And I'm not sure what help that is, but as you talk about launch director traditions, that's one of them. Just make sure that the family knows that that what's what's at stake here.
There was a question in there about how close you get to the crews, and does that add to the pressure? But it's what you're saying is, yes, you get to know them, and it's really
You do.
important that you
Oh
do.
yeah. And,
Yes.
and, and what, yes, and you do. You feel it may be a stretch to say you know them, because you don't know everything about them, but you know they recognize you and you recognize them. So in that sense, you know them. Yeah, it's a
Right.
it's a it's the flight crews are are again, you got to remember that's what it's all about. They and they like to be reminded that that's what it's all about. The I think I mentioned about uh, continuing to fly in the shuttle. It's yeah, it was not the right thing to do. Um, in commercial launch, commercial launch. On this advisory panel I was on with SpaceX, we kind of powered down, so to speak, after they had the first crew demo flight. The purpose of the panel was to help SpaceX get through the certification process to get NASA comfortable with how they were doing business and their approach to certifying that the crew module was really going to be human rated and based on our experience with NASA. So the panel had 3 retired astronauts on it, myself, and two retired NASA people that were really smart in their fields. One was a flight surgeon who was an expert in crew recovery operations, and the other was director at Ames for a number of years and was a principal in the Columbia Accident Investigation Board. In fact, he did most of the steerage of the technical stuff in there, and now he's a professor at Stanford. But our whole purpose was to to train SpaceX on what NASA would consider to be the hard points and the slippery spots. And in a feedback to NASA, NASA learned a lot from SpaceX. It went both ways. They did. And SpaceX had some bad days, and they got properly admonished by NASA. And that it's good that it happened to them. They learned the hard way. They haven't had their really bad day yet. I hope they never do. I hope we never add any more names to the Astronaut Memorial Foundation memorial that's out there at the Cape. But it's there are risks in human spaceflight. The and I think, and you're looking at the future. It's uh, it's Artemis. Artemis is unfortunately it's not the same NASA I was with
Right.
back in the days. There's a lot more levels of bureaucracy, and they don't enjoy the unlimited resources we did back in Apollo program. You think about, why were successful back then? Um, we we had at one point in time there was probably 500,000 people in this country signing time cards that they worked on some component of the Apollo program, be it a switch or a meter or whatever. And we had 25,000 people out here at, at KSC. 10,000 were housed in the VAB, Administrative Home for 10,000 people.
Wow.
Can you imagine that? The traffic jams that we had, and yeah, particularly when there was picketers and yeah, demonstrations. That was so unlimited resources in a society that was not as risk adverse as today, a management system that was very accommodating and taking care of the workers. Even when the layoffs came up, they made it a point by saying whatever you still need to have to be successful, we're going to do it. If something needed painting or the grass needed mowing, they made it a place, they made everything look like it was going to be used for another 10 years. Uh, it was, but it was, they kept everybody pumped. And as a result, at the end of the Apollo program, people could hold their head high and say, yeah, we did it.
Right.
Um, it's, it's a, uh, it's and I think it's a, we were talking earlier about what's the long pole that maybe to getting further out there and getting more done with Artemis and more longer duration space flights. It's I think that it's it the tough sell is going to be um, the expense and the benefit in return. But the technical challenge is, I'm an engineer, right? So I believe engineering will solve. If we got to get there faster, we'll come up with a propulsion system. If we got to find some lightweight materials uh, that'll give us a, a gain in performance to get there faster, we'll do it. And mitigate the effects of radiation and that sort of thing. I think the big challenge is going to be medical. Pretty much where I started in the program. Is this human body made for that long duration of the different gravity than it was born into?
Right.
Yeah. I mean, I probably shouldn't get into that, and I know nothing about medicine, but all that research we're doing up there now in the space station, most of it is medical related, and most of it is telling us that we were born to be on this rock, and and we better take care of this in our atmosphere, because we may find that long duration stuff out there, the body, including this very important part of the body, is was not it was meant for this environment. We'll see. We can be surprised. Remember the Antarctic expedition, Shackelford, and the crew that was given up for lost after how many months or whatever, and then almost a year later they emerged almost to the person because
We're
of
we're resilient,
perseverance.
right?
Yeah. So I don't. I'll never second guess what we're capable of doing.
I know we're a little past time. I'd like to just take it to 10:30 if that's okay with you, Bob, and get a few more
Sure.
questions. There were a couple that were put into the Q&A, and let me get Carl asked a couple of questions, and let me get to uh, more kind of procedural things. But he asked about when you're talking, who are you? When you're as a launch director. Let me see if I can find it there. Okay. At the time of the countdown, who are you in direct communication with when you're on your headset? Are
Yeah.
you talking to the rest of, all of the people manning the consoles, or how is that working?
No, I'm talking to the for the most part, it's not the people in the primary control room. It's the backup engineering people. It's the flight director, the range, the the outliers that are there, dotted line, to see, to in some cases tell them, okay, you're hearing this on the net, but just so you know, this is where I'm assessing this to be. Uh, and in some cases, they're they're telling me about some of the things that they're dealing with that may or may not be a factor in it. But if there's technical issues going on in the launch countdown, it's I'm usually listening to and talking to the backup control room, which is the engineers that have the luxury to lay stuff out on tables, go back through old data files and see if this out of family characteristic in this pressure or temperature or whatever has been a common occurrence in the past, or whether it's something that we really need to get onto. Uh, there's always a lot of communication off the primary net to the control room with the safety folks. They're constantly in my ear and vice versa. And usually the range, bless their heart, they back in the day when they didn't have the ability that they have today, it was they a number of times were could become a real annoyance. But hey, I understand the role. It's public safety, safety first, and it just became maddening sometimes when they would talk about their problems, and I'm thinking, you know, we give you lots of money to support a launch, safety and mission assurance coupled together. Why, why can't you fix your stuff and not cause another scrub and all of that? Speaking of safety, hazardous exposure that we have to go through again. People, even astronauts. I was surprised. I didn't find this out till after the launch, after I retired, that a lot of them never realized how much liquid hydrogen and liquid oxygen we replenished into the external tank that's already got 500,000 gallons in it. It's boiling off every
Right.
10 seconds with these replenishment valves, up to 240 gallons a minute of liquid hydrogen and liquid oxygen up to 1 to 200 gallons a minute simultaneously. That's hazardous. And people take it for granted. Okay, we're in stable replenish now. Everything is fine. No, that's a this kind of time.
Right.
It's agonizing. You go through that for after you've loaded the tank, it's almost 5 hours, even if you're on time to get launched again. You got people going back and forth to the launch pad, and no, it's a testy time, really. Anyway, the
You mentioned earlier about the red team. I remember during the third and successful launch attempt of Artemis, the launch director had to send the red team out there to take care of a leak,
yeah,
and that's obviously a risky thing.
it
Did
is.
how many times did you have to do that, or was that it's probably an infrequent thing, right?
It's a I would say, well, I probably one out of every somewhere between 3 and 4 times
Oh,
we had to either into the facility that's underneath the mobile launch platform, which is called the propellant transfer control room, but it's just a bunch of racks of equipment, and or inside the mobile launch platform itself. Both are it's not easy to, to get away from harm's way in a hurry. Let's put it
right.
that way. And again, sitting above you is 500,000 gallons of liquid hydrogen and oxygen that you're replenishing constantly at the rate of hundreds of gallons a minute.
Yeah, I remember they commenting that it's like the spacecraft is alive with all the noises that are happening.
Yeah, well, it is because this stuff's at cryogenic temperature, so there's creaks and groans and pops and bangs, and yeah, very unsettling environment.
Let me share one picture here. So let me do that now. Let's get that up. And let me just go back to and you shared this picture earlier with me.
Oh yeah.
And so, how much did you talk to Charlie about, you know, things to expect as a launch director? Now you get her with Mike Lineback, also a shuttle launch director. So
I would, yeah,
you're a
I
select
would
group,
say
right?
we probably were out there um, after Mike retired, probably at least once a year, maybe twice a year, leading up to Artemis 1. Yeah. And she would have questions, and 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 we would think of something else, say, well, if you got there's something else we didn't mention to you the previous time, or an experience that I want to share with you, it may be helpful because you may run into it sometime. But for the most part, she sought counsel from us, and uh,
Right.
and of course I never give up an excuse to go out to the space center, right? So
What is the team doing? What is the launch team doing now? Because they don't have Artemis 2 yet there at the Space Center, and it looks like it's going to be delayed now until 2025 at some point. So how is the team preparing when because
well, they do. It's yeah, it's a real test of patience. I feel for them. There's not a lot uh, other than maintaining the ground hardware, which is a constant job, by the way, because of the environment out there, the corrosive effects of the being that close to the ocean. Lots of simulations, lots of training, uh, cross training and the other skills. It's that's pretty much all they can do to stay together. And but it's tough. It was tough getting ready for the lean years, getting up to Artemis 1 because it didn't have the hardware. Um, Now they did tanking tests, and actually the people when they did their tankings for firings up at in Mississippi, the and the loading demonstrations and the engine firings. The Cape is tied into that, um, as part of a learning curve, and so that's good. There's a lot of effort to to keep them more than just busy, but to keep them sharp, and current with what's going on. Um, that's a big. It's a tough job for management, and particularly with the other contractors, the new folks I call them that are really stepping up their activity. They're hiring, and yeah, so it's not easy time for them.
I'll get two last questions in. There was a question about the Artemis 2 mission and the risks associated with sending them around the moon. You were part of Apollo, which had obviously we tested the lunar module first in Earth orbit before we took it to lunar orbit. I don't know if you know enough about what's going on with the planning, but how do you feel about that Artemis 2 mission going around the moon?
The Well, I think it, it's like an Apollo 8 mission,
Right.
and yeah, and and I'm glad they're doing it that way. I don't. I think the test they did with Artemis 1, although the major critical components were not there, so to speak, particularly the engine they're going to use to circularize. But I think they've I give NASA credit and the contractors. They've assessed the risk, and they've accepted it, and that's certainly good enough for me. They I think that a test in the Artemis the Artemis concept has a lot of things yet to be proven, and before it can be pulled off. This in in space refueling of cryogenics, for instance. There's a scheme for that, but it's never been demonstrated, and you kind of wonder whether, from a technology readiness level standpoint, we're really ready to do that. But that's part of the concept that's got to work. Um, so we'll see. Again, engineers are involved, so I'll pat them on the back and say, "Go for it."
Right.
You'll figure it out because you have to. It's a technical issue. You can solve technical issues. Yeah. But again, the medical stuff, there may not technical may not work for that.
Right. Well, one last question, Bob, because it's been great. I know we could probably go on for a long time and go through more questions, but someone did ask about any plans to write a book about your experiences. You've got a lot to share, and we've got someone on right now. I saw a comment from Jonathan Ward just thanking you for your involvement in the space program and all that. Maybe he'll be willing to assist you.
Well, I'd probably, if I was going to choose somebody, I would choose Jonathan because I've done some I'll call it work with John in the past, but he he's dedicated to do it right. If he's going to take the challenge of writing a book or be the ghost writer, as it were, uh, he's the right person to do it, because, and I like him for that, because his attention to detail is would make him a really good engineer in the business that yeah I'm in. But John, if you're listening, say I do appreciate the tweak, because I have not. I know my kids and grandchildren don't really know what dad or grandpa did, because you try not to share the some of the pains of work when you get home, you know, and and I'm sure they wonder, what did dad or grandpa do out there all those days and nights, and why did he get all those phone calls at night, and and yeah, and And the best way to do that would be write something, at least memoirs. Maybe John could help him with memoirs.
There you go. No, very good, Bob. Well, I really just want to thank you so much first for as a number of comments in the chat, thanking you for all your years of service to NASA and to human space exploration. So it's been great to get to talk to you here and share your stories with our NSS members. So thank you so much. We really appreciate taking the time to do this.
Okay, well, thanks, Bert, and all of you out there on the net. Thanks. Yeah,
Yep.
thanks for listening.
Yep, what I'll do now, everybody, I'm just going to share my screen one last time and bring up my last slide deck here. Let me just do this first before I share the screen. There we go. I'm getting there, everybody. I'll just take a second here. So again, I want to thank everybody for joining us tonight. I will share my screen right here. There we go. And so again, everybody, remember, we won't be doing another event, another space forum until after the ISDC. So look for our announcements, soon after that. It'll be after Memorial Day here in the States. For those of you who are in our time zone, just thank you and have a great evening. For those of you in tomorrow's time zone, have a great day, and of course, have a great weekend. Wishing everybody stay safe. We look forward to seeing you again after the ISDC. And just to let everyone know too, the ISDC in 2025 is going to be in Orlando. So we hope to make use of all of our connections here on the Space Coast to make it a really exciting one. But thank you all again for joining us and wishing you well, and we'll see you next time.